Welcome to Mobile Math, Math Lessons on the Go. Today's learning goal, by the end of this lesson, I should be able to subtract negative numbers from other numbers, either positive or negative, without the use of a calculator or any other technology. So this is part two. First part we did adding, this time we're going to look at subtracting. So when we are asked to find the difference of two numbers, we're being asked to subtract or take away. So just a reminder that difference, subtract, and take away all have similar meaning. From the previous video, subtracting 1.5, we had the big idea that adding a negative value gives the same result as subtracting a positive value. So if you could see here, adding a negative gives me the same result as subtracting a positive. So in this case, the answer is 2 for both. So that's from the previous video. So if that's a little rusty, you may wish to go back and watch that again. We'll get a little bit of a warm-up and review going here. So I'm going to use my integer chip model to show -3 take away 4 positives. So I'm starting with 3 negative chips, and I'm going to take away 4 positive chips. So I'm going to come over here, highlight my 4 positive chips, delete them, and then just count up how many negative chips are left over. And I should notice that there is a total of -7. So by taking away the positive chips, I'm actually making the problem more negative. Hence, we ended up with a -7. So subtracting negative values, please pay attention. This is a bit of a tricky section, and it does cause lots of people grief. So if we pay attention, though, we could probably get this pretty quickly. So again, I'm going to start with an integer chip model, and I want to show 2 positives, in this case 2 minus -3, so 2 positive chips take away 3 negative chips. So you can see I'm starting with 2 positives down here, unbalanced on the left-hand side of the table, and I am going to take away or remove these 3 negatives. So if I highlight those all together, and then I'm going to hit delete, you'll notice that by removing those negatives, I have actually made the overall problem more positive. So the answer here is +5, which might be a bit of a surprise for some people. But let's try one more just to make sure we're getting the idea. So I'm going to have 1 minus or take away -4. So I have 1 positive chip, and I'm going to take away 4 negative chips. So you can see on my table here, I have an unbalanced 1 here, and I am going to take away these 4 negatives. So boom, they're gone. And now you'll notice there is an unbalanced total of 5 positive chips. So there is a bit of a shortcut or an observation we can make here that might make our lives a little easier. When I look at 5 plus 2, I'm going to add 2 positive chips to my group of 5, and I will get a total value of 7. If I come over here to the 5 minus -2, this says take away 2 negative chips from this total. So if I highlight these 2 negatives and I delete them, you'll notice I end up with, wow, 7 positive chips as well. So both of these answers yielded a result of 7. And that leads to our next big idea, and this is a really tricky one, so take a second to read it. Pause it if you have to. Subtracting a negative value gives the same result as adding a positive value. Now that's pretty wordy, so I've included a little bit of a picture here. Subtracting a negative value gives me the same as adding a positive value. Now what I do get is a lot of students saying, hey, there's those 2 negatives there together can kind of look like they turn into a positive. That's not very mathematical, but I totally understand where their shortcut's coming from. But again, I want to reiterate, subtracting a negative value gives the same result as adding a positive value. So let's try and put that into practice shortly here. So a quick summary of our subtracting rules. I've just gone through both of those, so this would be a good time to pause, really read these through and make sure you're comfortable with them. And let's try one here. So I've got two models that I'm going to use my big ideas on. The first one is -3, take away 2 more negatives. Oh, I better start again. -3, subtract or take away 2 negative chips, take away 1 more negative chip. So you can see I have an unbalanced -3 here. I want to take away 2 negatives. So if I grab these 2 negatives on the bottom and I delete them, and then I'm going to take away 1 more negative, and I will delete that one. You'll notice that I have a balanced situation here where all of my chips are zeroed out. So the answer here is actually 0. So I'm going to approach the exact same problem, only I'm going to use one of the big ideas. Instead of subtracting a negative, I'm going to interpret that as adding a positive. Instead of subtracting a -1, I'm going to take that as adding a +1. So I'm starting with -3 chips here on the right-hand side. I'm going to add 2 positives, and then add 1 more positive, and wow, there's a big shocker. Everything zeroes out, and I get the exact same answer. So our big ideas still work, which is awesome. So we can add those to our math toolbox. So I'm going to ask you to pause the video right now and try these 2 questions. They're already sort of set up for you. So just hit pause, and I'll get the answers to you in 1 second. Welcome back. So we're going to start with -4, expressed right here. And this says take away 3 negatives. So if I highlight those 3 negatives and I delete them, I can see that after I cross off my unbalanced or my balanced chips or my 0 pairs, I am left with 1 negative for the first one. Second example, B, I have 5, take away 1 negative chip, take away 2 more negative chips. So if I wanted to write that using our big idea rule, I could also write it this way. Those would be equivalent. So let's see what happens. So I'm starting with my 5 unbalanced positive chips. Take away 1 chip. There it goes. Take away 2 more negative chips. There they go. And I get an unbalanced value of 8 positive chips. So thank you for watching. Please watch again and pause where you may have had difficulties. And good luck in your future math problems.